One card is drawn at random from a standard 52 card deck. Determine whether the events E and F are mutually exclusive, and then find the probability of E union F. That is the probability that either E or F occurs. So in part A of this question, the card is a face card. If the card is a face card, that would be event E, and if the card is a club, that would be event F. These events are not mutually exclusive since, I'm just going to use ME for mutually exclusive, since in fact there are 3 face cards that are clubs. So when we do the computation, the probability that the card that is drawn is either a face card or a club is not just the probability that it's a face card plus the probability it's a club, because that would overcount by 3. We have to subtract the probability that both occur at the same time, which they can, because the Jack, Queen, and King of clubs are both clubs and face cards. So here we would have 12 over 52 for probability of a face card, plus 13 over 52 for the probability of a club, but then we take 3 over 52 away because there are 3 face cards that are clubs. So we have 22 over 52, which reduces to 11 over 26. In the second case, part B, we have the event that the card is a heart is E, and the event that the card is a club is F. There's no clubs that are also hearts, so this is mutually exclusive. So in this case, the probability of E union F, probability of a heart or a club, is the probability of the first event plus the probability of the second event. Still subtract the probability of the intersection, but the intersection in this case is 0. So the probability of the heart was 13 over 52. The probability of the club is 13 over 52. So we get 26 over 52, which is 1/2. Half of the cards in the deck are either a heart or a club. So let's go to the next problem, which is very similar to this one. And here we have in part A that the card is a diamond would be event E, and the card is a queen would be event F. Well, since there is a queen of diamonds, this case we do not have the events being mutually exclusive. So the probability of E union F is the probability that the card is a diamond plus the probability that the card is a queen minus the probability that the card is a queen of diamonds. And there's one way that that can occur. So this is going to equal 13 over 52 plus 4 over 52. There are 4 queens, but we have to take 1 over 52 away because of the queen of diamonds. So this leaves us with 16 over 52, or 4 over 13 as the probability. Part B here has the identical answer, since we've got 1 8 of diamonds. And so this 4 over 13 would be 4 over 52 for the probability of an 8 plus 13 over 52 for the probability of a diamond minus 1 over 52 for the probability of an 8 of diamonds. And again, this is not mutually exclusive. We've got one more problem in this set. And this is a category where we have the word at least in our advent, and we need to be a little careful with these. So if a 5-card poker hand is drawn from a standard 52 card deck, find the probability that at least one card is a heart. So we certainly could do this the long way and find the number of hands where there was 1 heart and 2 hearts, 3 hearts, 4 hearts, 5 hearts using combinations. But it would be easier for us to say that at least 1 heart is the complement of no hearts. So the probability of at least 1 heart would be equal to 1 minus the probability of no hearts. And counting the probability of no hearts is easier, or computing the probability of no hearts is easier. And so this would give us 1 minus. So how many ways can we choose a hand with no hearts, a 5-card hand? Well, 39 of the cards are not hearts. So 39C5 divided by 52C5. That would be the probability of no hearts. And so, looking at our calculator here, we'll have 1 minus 39, math, prob, combinations, 5 divided by 52, math, prob, combinations, 5. And that gives us 0.778. And so we'd have 0.778 is the probability. So the probability is a little bit more than 75%. The probability that at least one card is a face card would equal 1 minus the probability of no face cards. This would be 1 minus, now we have to think for a minute, 12 of the cards are face cards, and so 40 of the cards are not. So 40C5 weighs to get a hand that does not have a face card over 52C5 ways to deal the hand. And so this time we'll go back to the calculator. 1 minus 40 math prob combination 5 divided by 52 math prob combinations 5. Enter, and we're getting just under 75%, 0.747. Is the probability that at least one card is a face card.